Hello, this will be a demonstration of Proposition 13 from Book 7 of Euclid's Elements, which says that if four numbers be proportional, they will also be proportional alternately. Just like some of the previous propositions, this has a counterpart in Book 5, namely Proposition 5.16, which was often used, and just as often as that one was used for magnitudes, this one will be so often used for numbers. We're of course given four numbers, such that the number a is to the number b just as the number c is to the number d. And what we're going to prove is that alternately, the first number is to the third just as the second is to the fourth. The definition of alternate proportion is just going to be directly carried over from Book 5. So that the number a is to the number c just as the number b is to the number d. Now, because the number a is to the number b just as the number c is to the number d, this was given to us, but the definition of proportionality, it of course follows that the number a is the same part or parts of the number b that the number c is of the number d. Again, we're assuming that the number a is less than the number b, and likewise that the number c is less than the number d. But if the number a is greater than b, then we can just invert the proportion and the proposition still holds. But we're just dealing with the former case. So the number a is the same part or parts of the number b that the number c is of the number d. Now, this being the case, by propositions 7.9 and 7.10, which establish this alternate relationship of parts. So if a first number be a part of the second, and if a first number be the same part of a second that a third is of a fourth, then whatever part or parts the first is of the third, the second shall be of the fourth. And likewise 7.10, if a first number be the same parts of a second that a third is of a fourth, then alternately whatever part or parts the first is of the third, the second shall be of the fourth. So that with those two propositions, the number a is the same part or parts of the number c that the number b is of the number d. Which then means, of course, by the definition of proportionality, we have a first number that is the same part or parts of a second that a third is of a fourth, which means that the number a is to the number c just as the number b is to the number d. And this is exactly what we set out to prove, which means we are done with the proposition, therefore, etc. q, e, d. Of course, an example of this would be that 6 is to 8, just as 9 is to 12, which means that alternately 6 is to 9, just as 8 is to 12. This example obviously holds, and so we see that this proposition does in fact hold. That's all I've got to say about this proposition, so I'll end the video here and move on to Prop 7.14.